Welcome, ladies and gentlemen. So what I'd like to do is just kind of go over what are the things you're going to need to know to be able to determine the end behavior. Now, when determining the end behavior, applying the leading coefficient test is probably one of the most important things that you're going to need to know. And when applying the leading coefficient test, you're obviously going to need to know what the degree is as well as what the leading coefficient is. And not only to determine what the degree is, but determine is your degree odd or even, and then determine if your leading coefficient is positive or negative. But that's pretty basic, but those are things you're going to need to know when applying the test. The next thing, I'm going to actually rewrite this, we're going to switch these around, but the next thing I think is very important for you to understand, the parent graphs. So the parent graphs, that's a horrible marker. The parent graphs here, two parent graphs I want to look at is y equals x to the first power and y equals x squared. So the parent graphs for each of these, the x squared here is our quadratic, and y to the x is our identity graph. They look like that. So it's important for us to understand, when looking at these parent graphs, is this is what a parent graph, or all graphs that are going to have an odd exponent and a positive leading coefficient are going to rise to the right, fall to the left. And all graphs that have a positive or have an even power and a positive leading coefficient are going to rise left, rise right. And then if I make it negative, then it's now going to be reflected about the x-axis. So therefore, it's still going to go in the opposite directions here. It's just now going to rise left, fall right. And here, rises or falls left, falls right. So the next thing, really the last thing, is understanding and being able to deliver your formal notation. Because, a lot of times we say rises right and falls left. Where in this case, I could say that it falls left and falls right. But a lot of times what we deal with when we're dealing with notation is this formal notation. And what formal notation basically looks at is our two axes. Let's say x and y. And let's do this one actually as a function, f of x. So we'd have the f of x function and our f of x axis and the x-axis. So basically what they're saying is as points, I'm going to use just I'm going to use the black graphs. As my x values of points on this graph go to the right, so I can say as x approaches infinity, because as I keep on going to the right, I'm eventually going to get to infinity, then my y values, the y values of these points also are going to go up, and that's going to go towards infinity. So as x approaches infinity, y approaches infinity. And as my x values now go to the left, that means they approach negative infinity. My y values, those are also going to approach negative infinity. So now let's look at an example over here. And we'll do, actually, let's do we'll do the black one again. So now as my x values go to the right, so that means as they go into infinity. So as x approaches infinity, now you can see we're talking about the f of x, right? Not the y, but the f of x values are also going to go up. So you could say f of x approaches infinity. And as my x approaches negative infinity, so as my x values go to the left, the f of x values go up to infinity. And there you go, ladies and gentlemen. That is how to determine that is the things that you're going to need to know for your end behavior. Thanks. I don't know why I went over all that.